Okay, guys, hopefully you watched the first video on independent probability. That's the one you want to watch first. So if you accidentally pick this one first, save this one for second. Okay? Now, same deal. I'm making a nice video here. I want you to watch this video. Take notes in your notebook. Enough said. Here we go. So we're going to learn dependent probability, which to me is the more realistic, real-life probability, as you'll find out. So for example, let's say over here, you could see we have a total of 8 cards, right? Some are white, some are black, okay? Now, you're not going to be able to see these cards again. They're going to be shuffled up, face down, so you won't know whether it's white or black, okay? So just keep that in mind. So what makes this problem different than the ones we just did in the last video is we're going to pick a card. We do not replace it. In other words, let's say I deal a card to you. I don't just take it back immediately, right? I may deal you a second card then. And then, of course, we pick a second card. So the key thing is we're not replacing. So what that's going to do is it's going to change the probability each time we deal or pick a card. All right? Hopefully you can follow along once we do a couple examples. For example, what's the chance of getting a black and then a white? Well, notice over here I have 1, 2, 3, 4, 5 black. So that's 5 out of 8 chances, right? 5 out of 8. But now what we have to realize is that one of those black cards is gone. We don't know which one. It doesn't matter which one we take. Let's say this is the one we dealt out. It's gone, right? You have it already in your hand. So now we're going to pick our second card, and we want it to be white. Well, notice there's 1, 2, 3 white, but there's only 7 cards, right? See, this right here is the difference. If I were to pick another card, now I'd be down to 6 cards, for example. And that's why I was saying earlier, this is a more realistic probability. It's like playing a game of cards and you're just dealing out the cards, right? Of course, you're not replacing the cards immediately, so the cards are just shrinking down one by one. But anyways, let's figure out our probability here. Let me clean up my mess here a little bit. That was 3 out of 7. So timesing across, that would be 15 out of 56. And you could try to reduce that, but you can't. Okay? Let's do one more in this example. Let's say we wanted to do white and then another white. Well, the chance of getting a white again, well, we didn't do the white the first time, not the first try anyways, is 3 out of 8, right? We're starting over. There's 1, 2, 3 whites out of 8 cards. So 3 out of 8. But one of these white cards is now gone because we dealt it. So notice, if I want a second white card, I only have 2 chances because the one card is gone, right? I only have 2 white cards left out of 7. So notice this number will always shrink by 1 if I'm not replacing it. Okay? And this number shrunk by 1 because I already picked one. So that's what you have to keep track of. This is why I was saying in class yesterday, with probability and statistics, you do have to think more than you generally do perhaps in a regular algebra problem. Okay? You really have to think about what's going on. But anyways, timesing this together, 3 times 2 is 6 out of 56. Now this one we can reduce, right? I could divide by 2, and I get 3 out of 28 chances. I have a 3 out of 28 chance of picking 2 whites in a row. All right, let's try a different kind of problem here. Okay, this time you can see we have the word banana over here. So we have 1 B, 3 A's, and 2 N's, right? So, again, these are cards. They're going to be face down where you don't see the letters. They're going to be scrambled and shuffled together, right? So they're going to be in a random order, as we say. So with that in mind, let's say we want to do B, then N. Well, the chance of getting that B is 1 out of 6. But remember, we are not replacing, without replacing. So that B is now gone. How many cards are left? That's right, only 5. Now we want to get an N on the second try. Well, there's 2 N's out of only 5. Notice this went down 1 because we did not replace the cards. So timesing together, we get 2 out of 30. Again, use your calculator, or hopefully you know to divide by 2. And the reduce perfect answer is 1 out of 15 chance. Okay, now let's do another one. How about we do A then B? Okay, well, the chance of getting an A is 3 of them, right? 3 out of 6 chance. But now, one of these A's is gone. That means there's only 5 cards left. What's the chance now of getting this B? 1 out of 5, when originally it was 1 out of 6. But remember, there's only 5 cards left because one of those A's is gone. So simplifying or timesing this across, we get 3 out of 30. We're going to simplify by dividing by 3. And we'll have a 1 out of 10 chance. Okay? Let's do one more here, guys. Now pay attention, because I want to make sure you understand this one. Here we go. Let's do this problem. What's the chance of getting a B then a second B? Okay, so we're going to pick the first B. We got a 1 out of 6 chance. But remember, that card is now gone. What's the chance of picking the second B? There is no second B. Therefore, it's a 0 out of 5 chance. And what's 0 out of 30? Well, of course, that's a 0 chance. In other words, 0 means no chance, right? 0 means impossible. Can't happen, right? And that happens in real life, right? Sometimes things just can't happen. Okay, so I just want to make sure you follow along with that. Let's see if we got one more here to look at. Okay, so this time we're back to a bag of marbles, one of the more common problems which I will actually quiz you on. All right, now notice there's 1, 2 green, 3 more blue, that's 5, 4 red, that makes a total of 9 marbles. So I hope you agree we have a total of 9 marbles there. Okay, so again, we're not replacing after we pick the first one. So how about we do, what's the chance of getting a green and a red? Well, to get the greens here, that's 2 out of 9. Now, one of these greens is going to be gone. We're not going to pick both of them. We're just going to, we know we have 2 of them. We get one of those green marbles out, right? Let's say it happens 2 out of 9 times. Now, with that green gone, notice there's only 8 marbles left. The chance of getting these reds is 4 out of the 8. So times together, that's 8 out of 72. If I was to reduce this, guys, I would actually divide by 8 here. I'm going to try to remember to show you how to reduce fractions on the calculator as well. And we get 1 out of 9 chance. 8 out of 72 is correct, guys, but it's not the perfect answer because it needs to be reduced, okay, to 1 out of 9. Let's do one more. How about we do not blue, then not blue again? Nah, that one's boring. We'll figure that one out in class maybe together tomorrow. How about red and then not blue? There we go. Okay, starting over here. We're back to 9 marbles. They're all mixed up in there, okay, guys? So now what? Well, the chance of getting that red is 4 out of 9. But one of these reds is gone. It doesn't matter which one. Let's say that one's gone. That means there's only 8 marbles left. What's the chance of not getting a blue? Well, we have 2 green that are not blue. And we have 3 red still that are not blue. So do you understand? That's 5 that are not blue out of 8. So we get 20 out of 72. Let's reduce that. I'm going to start by dividing by 2 here. And that's going to be 10 out of 36. Let's divide by 2 again. That's 5 out of 18. and that can't be reduced anymore. So guys, hopefully you're now understanding dependent probability, okay? The more realistic life kind of probability. I will see you tomorrow in class. Make sure you get these notes in your notebook. That's all I need from you today. Watch these videos. Take good notes. I'll see you tomorrow.